So in last class we were looking at evaluating double integrals over rectangular region. Now we will look at double integrals in the non-rectangular region, or that is integrals with non-constant limits of integration. So these are actually double integrals over non-rectangular region. So whenever you have an integral where both the limits, whether you have integral of the form integral a to b, c to d, f of x, y, dA, so where the order can be either dx, dy or dy, dx, it will be a rectangular region. അപ്പം a to b ഒരു വേരിയബിളിന്റെ വേരി ചെയ്യുന്ന ഇന്റർവൽ ആയിരിക്കും, and c to d is the interval of variation of the other variable. So here when you have all the limit values as constant, then the underlying region is a rectangular region. Now we can have non-constant limits of integration when and this happens when the region is non-rectangular. Okay, so when you have a non-rectangular region, the outer integral will always have constant limit. Okay, from outer integral eppozhum constant limit aayirikkum. The inside integral can be variables. So here c and d, they will be either functions of x like functions of y. So let us look at the forms of limits integrals with non-constant limits of integration. So when you consider double integrals, the two types of integrals with non-constant limits of integration, they are of the form integral a to b, then you can have limits to be function of x. So y can vary from, so here x varies from a to b and y will vary from g1 of x to g2 of y, f of xy, dy, dx. So this is one form of integral where you have non-constant limits of integration. And the second type of integral is, so you can have integral of the form c to d. So here y varies from c to d and x will vary from, say, from h1 of y to h2 of y. So you have f of xy, dx, dy. So these are the two forms of integrals involving non-constant limit of integration. So these are the form of limits. So outer limit eppozhum constant aayirikkum. The inner limit can vary from a function of x to function of x, or a function of y to a function of y. So these are the non-constant limits of integration. So let us first see how to evaluate the limit from how to evaluate the integral. So let us look at an example. So evaluate. So the first problem is integral 0 to 1, then minus x to x square, y square x dy, dx, and then 0 to pi by 3, then 0 to cos y x sin y dx d. So for the first integral, the notion of integration remains the same. അപ്പോൾ ആദ്യം നമ്മൾ y വെച്ചാണ് ഇൻ്റഗ്രേറ്റ് ചെയ്യുന്നത്. സോ ഇൻ്റഗ്രേറ്റ് പാർഷ്യലി വിത്ത് റെസ്പെക്ട് ടു y, കീപ്പിംഗ് എക്സ് ടു ബി കോൺസ്റ്റൻറ്റ്. എന്നിട്ട് നമുക്ക് വൈക്ക് ലിമിറ്റ്സ് അപ്ലൈ ചെയ്യണം. വൈയുടെ ലിമിറ്റ്സ് മൈനസ് എക്സും എക്സ് സ്ക്വയറും ആണ്. സോ ദ ഹോൾ തിങ്, അപ്പോൾ വൈക്ക് നമ്മൾ എക്സിൻ്റെ ടേംസ് റീപ്ലേസ് ചെയ്തു. സോ ഹോൾ ഫംഗ്ഷൻ will reduce in terms of x. Then the second integral will be, the integrand will be a function of x. You need to integrate with respect to x. So after the first integration, it will reduce to a function of single variable. That will be either x or y. എന്നിട്ട് usually integrate ചെയ്യുന്ന പോലെ ചെയ്യാം. So that is the same idea. The way of integrating is the same as what you did for the rectangular case, but here the only difference is for the inside integral you will have non-constant limit of integration. Okay. So here ആദ്യം y വെച്ച് integrate ചെയ്യുക. So x will be a constant, y square and integral y cube by 3 from minus x to x square dx വരും. So that is integral 0 to 1 x by 3. Now we take limit of limit. So that will give you x raised to 6 minus then you have minus x whole cube, so plus x cube dx varum. Now this will be equal to integral 0 to 1 x raised to 7 by 3 plus x raised to 4 by 3 dx. So that will be 1 by 3 x raised to 8 by 8 plus x raised to 5 by 5 from 0 to 1. So that is 1 by 3. So when you apply the limits on this function, you will get 1 by 8 plus 1 by 5. So that is 13 by 120. So that is the required value. Now the second integral. So first we need to integrate with respect to x. For x which integrate ചെയ്യുമ്പോൾ x into integral x square by 2. So applying the limits from 0 to cos y dy varum. So getting integral 0 to pi by 3 sin square y into sin y cos square y by 2 dy. Now using substitution, du equal to cos y, so du will be minus sin y dy, and u will vary from, so cos 0 is 1, cos pi by 3 is 1 by 2, so we'll get minus u square du by 2. So upon integrating, you will get minus u cube by 3 into 2 varum, and apply the limits from 1 to 1 by 2. So we will get minus 1 by 2 into 3. So we will get 1 by 8 minus 1. So upon simplifying, the value of the integral is going to be 7 by 48. So this is how we evaluate an integral with non-constant limit. So now let us look into these two types of regions. Upon first type of integral where y is varying from g1 of x to g2 of x is called as a region of type 1. The type 1 region എന്ന് പറയുന്നത് you have y varying from g1 of x to g2 and x varies from a to b. And the second type of example we have seen is called a type 2 region where your region is from x equal to h1 of y to x equal to h2 of y. Now let us look at how to form the limits of integration. അപ്പോൾ നമുക്ക് ഒരു റീജൻ തന്നിരിക്കുകയാണ്, എക്സ് പ്ലെയിനിൽ ഒരു റീജൻ തന്നിരിക്കുകയാണെങ്കിൽ എങ്ങനെയാണ് ലിമിറ്റ്സ് കൺസ്ട്രക്ട് ചെയ്യുന്നത്, and then we will look at how to reverse the order. For rectangular region, by Fubini's theorem, if you simply interchange the limits, the integral remains the same. അപ്പോൾ ഞാൻ dx dy or dy dx ആയിട്ട് integral evaluate ചെയ്യുമ്പോൾ the integral remains the same, but you cannot do the same thing in case of a non-rectangular region. So there then you cannot simply reverse the order of integration. അതിനനുസരിച്ച് ലിമിറ്റ്സിന് മാറ്റം ഉണ്ടാകും. ബട്ട് ഇൻ ദ കേസ് ഓഫ് റെക്ടാങ്കുലർ റീജിയൻ നമ്മൾ ഡി എക്സ് ഡി വൈയോ ഡി വൈ ഡി എക്സോ എഴുതുമ്പോൾ ലിമിറ്റ്സ് ഇൻ്റർചേഞ്ച് ചെയ്യുക. ബട്ട് ഹിയർ ദി ഫങ്ഷൻ, the whole function changes when, that means the bounds of the limit changes when you reverse the order of integration. So we will look at how to determine the limits of integration when you have a region which is of type 1 and when you have a region of type 2. Let's now define the type 1 region. Now by type 1 region, we mean, so that is a region which is bounded on the left by left and right by the vertical lines x equal to a and x equal to b, and is bounded below and above by continuous functions y equal to g1 of x and y equal to g2 of x, where g1 of x is less than or equal to g2 of x for x equal to a to b. So a region of this form is called the type 1 region. അപ്പം ആദ്യം നമ്മൾ കണ്ട ഇന്റഗ്രൽ ഈ ഫോം ആയിരുന്നു. So x varies from a to b and y varies from g1 of x to g2 of y f dy dx. So here we have a region where the region is bounded below and above by g1 and g2 and on the left and right by x equal to a and x equal to b. So the region of this form is called as the type 1 region, and by type 2 region we mean that's a region which is bounded above and below by the lines, horizontal lines c and d, that is y equal to c and y equal to d, and on the left it is bounded by x equal to h1 of y and and on the right by x equal to h2 of y. So here h1 of y is less than or equal to h2 of y for all c less than or equal to y less than or equal to d. അപ്പോൾ നമ്മൾ കണ്ട ഇന്റഗ്രൽ ഇങ്ങനെയാണ്. ടൈപ്പ് 2 ഇന്റഗ്രൽ വരുന്ന ഇന്റഗ്രൽ c to d, then h1 of y to h2 of y f dx dy വരും. So this is an integral of type 2 form. So that is the type 2 region. So here y is constant and x is having non-constant limit. Type 1 x is constant and y is having non-constant limits. And now let us see how to find out the limits of integration in the form of type 1 and type 2. Let us look at how to set up the limits for a region of the form type 1. So this is the form of type 1 region. You have the left and right bounds to be x equal to a and x equal to b, and it is bounded below by y equal to g1 of x and above by y equal to g2 of x. Now for finding the limits, there are two steps. So the first step is we need to draw a vertical line through the region R. So this is our region R. So draw a vertical line through this region. ഇനി നമ്മുടെ ഈ vertical line given region-ലെ രണ്ട് points-ൽ intersect ചെയ്യും. So it will intersect on these two curves which are forming the boundary. So the lower point of intersection gives the is on the curve y equal to g1 of x, and the upper point of intersection will be on the curve y equal to g2 of x. ഇപ്പോൾ ഒരു vertical line വരയ്ക്കുക. vertical point തന്നിരിക്കുന്ന region-നെ രണ്ട് points-ൽ intersect ചെയ്യും. So the lower point of intersection will be on the curve g1, which is going to be the lower limit, and the higher point is on the upper curve, so which gives the upper limit as g2 of x. ഇനി സ്റ്റെപ്പ് 2-ൽ ചെയ്യുന്നതാണ് തന്നിരിക്കുന്ന റീജിയനിൽ ഈ ലൈനിനെ ലെഫ്റ്റിലേക്കും റൈറ്റിലേക്കും മൂവ് ചെയ്യുക. എന്നിട്ട് ലെഫ്റ്റിൽ ഏറ്റവും മിനിമം വാല്യൂ ഏതാണ് എടുക്കുന്നതെന്ന് നോക്കുക. Okay, so in the leftmost, when you move left towards left, so the minimum value where the region and the line intersect will be x equal to a. അതുപോലെ റൈറ്റിലേക്ക് മൂവ് ചെയ്യുമ്പം the line intersect with the region R at x equal to b. So that gives the outer limits, and the lower limit will be x equal to a and the upper limit will be x equal to b.